So today in this video we'll be studying about the refraction of light through a prism. Now let us first understand what exactly the prism is. A triangular prism is a homogeneous, transparent refracting medium, usually glass, bound by two non-parallel refracting surfaces inclined at some angle. You can also understand this by looking at this picture. This is the picture of the triangular glass prism, and this is the upper face that is triangular in shape, and that is why we refer it as the triangular prism. Now what happens when the ray of light travels through this prism? For oblique incidence on one face of the glass slab, we find that the emergent ray is parallel to the incident ray but has undergone a slight lateral displacement. Now, what is the meaning of emergent ray and incident ray is? See, incident ray is the ray that is incident or that is falling on the prism. Let us say if this is the refracting surface, this is the incident ray that is falling on it. An emergent ray is the ray that is coming out of the prism after refraction. So, for oblique incidence, it is observed that the emergent ray, that is the ray that is coming out of the prism, is actually parallel to the incident ray, but it is shifted by slight lateral displacement. Let's see what's meaning of that. So, the angle between two refracting surfaces is known as the angle of prism. But let's just first understand what these two refracting surfaces are. See, A, B, E, D, this is one refracting surface, and another one is A, C, F, D. Okay, it is also written over here that A, B, E, D and A, C, F, D are the two refractive surfaces of the prism. Further, the line AD, which is here, this from A to D, which intersects these two refracting surfaces is known as the refracting edge of the prism. So this AD, it is also labeled here that AD is the refracting edge. Further, angle BAC is the angle of prism, which is also the angle between two refracting surfaces of the prism. It is usually denoted by the letter angle A. The surface BCFE is called the base of the prism. You can also see this over here, BCFE, that is the base of the prism over which the prism stands, you can say. The base of a prism is usually grounded so as to make it non-refracting. It is also shown in the picture BABC. This is actually not the base. It represents the front face of the triangular prism, ABC. Next is a section of the prism that is perpendicular to its refracting edges is called as the principal section. This is actually what I was explaining to you earlier, that is the front face of the prism, ABC. It is also known as the principal section of the prism. So ABC is the principal section of the prism. Usually a triangular prism is simply called a prism, and for the purpose of ray diagrams, the principal section ABC is drawn to draw a prism. Like this actually represents a prism only. We only show the prism by drawing this because we have the paper in two-dimensional, right? Like when we draw on paper, it is a two-dimensional figure. So in order to represent a prism on the paper, we represent it like this instead of this because it gets too confusing if we draw this on the sheet. Okay, now let's just understand how does the light refracts through the prism. This is the experimental study of refraction of light through the glass prism. So what you need to do for that is, see, this is the principal section of the prism that we studied in the previous slide, right? So in order to understand the refraction of light through this prism, what you need to do is to fix a white sheet on the drawing board with pins or tape And now place the glass prism on its triangular base and trace its outline as ABC. ABC, right? Now what you need to do is you need to draw an inclined line PE, this PE on the face AB, and you need to fix two pins. See, they are marked here as well, P and Q. You need to fix two pins here. Now what you need to do next is to look through these pins from this particular face, that is AC face. When you look through face AC, you need to align the pins R and S with the images of P and Q. Okay, so mark the pinprick points, remove the pins and the prism. So these are the points that you have marked, the R and S. Now join the points R and S. You need to join these points, extending the line up to F so that it meets AC at point F. Similarly, the line PQE meets the AB, this face AB, at point E to complete the line EF. So just join the points E and F to complete the line EF. Now the next thing that you need to do is to draw perpendicular NN dash to face AB. Like this is the perpendicular that you will be drawing, NN dash on the face AB and MM dash on the face AC. Now identify the rays as, see, this PE ray is the incident ray, this EF ray is the refracted ray, and RS ray is the emergent ray. Now, in order to measure the angle of incidence, because angle of incidence is the angle between incident ray and the normal. So this will be the angle of incidence. And angle of refraction is the angle between the refracted ray and the normal. So this will be the angle of refraction. Similarly, we can calculate the angle of emergence as angle E. This is angle of emergence, the angle with which the radiation or the ray is emitted outside. Measure the refracted angles R1 and R2, and you can extend the incident and the emergent rays until they meet at point G. So this was the original path of the incident ray P, Q, E, G, H, right? This was supposed to be the path of incident ray. However, it got refracted in this direction, RS. Now, if we trace it backwards, so the angle FDH will give us the angle of deviation that has been produced in the incident ray. It tells us the extent up to which the incident ray has been deflected from its original path. So measure angle HGF, which is the angle of deviation caused by the refraction through the prism. So that's all about it. I hope this topic is clear to you. Thank you.